Investigation of reptile UV bulb on vitamin D2 synthesis in pulverized mushrooms and analysis over specific durations using thin layer chromatography. Nearly 2/3 of Americans are deficient in vitamin D2, which is crucial for bone health. You can also find vitamin D2 through food sources like tuna, egg, milk, and mushrooms. But mushrooms are one of the least vegan options for vitamin D2, and which also, if they're exposed to sunlight, it has a precursor called ergosterol, which can be converted to vitamin D2. My research specifically focuses on the analysis of how the intensity of vitamin D2 production in oyster mushroom will be affected by the duration of pulverized mushrooms when exposed to UV. And I hypothesized that an increase in UV exposure would increase the vitamin D2 production. And as for my results, this hypothesis was proven right, because the RF values, the retention factor values of the mushrooms, increased as the duration time increased, and which is also shown by the graph below. And then it also levels off on the top, showing that the increase of the UV exposure could level off the amount of vitamin D2 produced. But these results were not quite accurate, because as you can see from the top image, the very first image, my TLC plates, the spots have not moved a lot, which showed me that my mobile phase was not polar enough for the vitamin D2 to travel up the TLC plates to give me more accurate results. So for future research, I'm going to utilize a more polar mobile phase for TLC to improve the separation of vitamin D2, and I might also use a small range, the same range with more durations, which would give me a deeper analysis of the RF value. And this will also give me a more accurate analysis overall of the RF value of the vitamin D2 intensity.